the product rule. So what is the product rule? Well, the product rule is a formula. You must pick your u function. The u function is the first part of the product, and your v function. Your v function is the second part of the product. You have your u, you have your v. With that, now you just gotta go look up the rule for the product rule. If you have a product of two functions, and you want its derivative, the rule is u prime times v plus u times v prime. You'll see alternate ways of writing it with f's and g's, and yes, some people write it u v prime first. That's fine. Remember, with addition, 3 plus 2 is 2 plus 3, so it doesn't matter. And multiplication is commutative, so it doesn't matter how you write it either, as long as you're consistent. This will work. So what do I do when I want the derivative? And remember, the symbol for the derivative is f prime, or you can also do df dx. And so what we have is the derivative of f with respect to x is the following. So how do we take the derivative using the product rule? And so what we have is I'm going to use this formula right here. And really, I like to draw my boxes out. I really like to take my time with this. I have u prime, I have v. And each one of these boxes goes those components of the formula. Then we have u and we have v prime. So here's my product rule. So how do I work with it? Well, I go slowly here. I have my u. Well, I've already picked my u. It's x squared plus 1. I've picked my v. That's 3x to the 4th plus x to the 10th power. All right, so what happens now? I take and do little by little each piece. So u prime would be the derivative of u. All right, so there we go. The derivative of u. This is good old rules. If you have a sum, you can take the derivative of each piece separately. The derivative of x squared is a power rule. You bring the power down, subtract 1, you get 2x to the first. The derivative of 1 is a constant, and that's 0. So there's my derivative. Nice. All right, v, the derivative of v prime. Well, that is a power rule, generalized power rule, or a chain rule. That is, I have a u to a v in some respects. I have a u to a power. I apologize. How do I take the derivative of this? Well, what I do is I bring the power down. I leave the inside alone, so I do not touch the inside, because that's what the chain rule says. You deal with the outside power first by a power rule, bring the power down, subtract 1 from the exponent, leave the inside alone. Now the chain rule goes on to state, now you must now deal with the inside derivative. So here we go. We must take the derivative of this expression on the inside. For more help with the chain rule, please see my chain rule video. So how do we take the derivative of this? Well, that's a power rule, 12x cubed plus, let's be careful here, the derivative of an x. Well, the derivative of x, or 1x, would be 1, because that's the coefficient in front of the x, our linear derivative. And so here you have it. There is your first derivative. That is the derivative of the function f with respect to the variable x, either way you want to write it. There's your derivative done by the product rule. Why was it a product rule one more time? Because we have the last operation up here, when I evaluate, would be a multiplication. That's why it's a product rule. Now, should we clean it up? Could we clean it up? Both are good answers, or good questions, I should say. We could definitely clean this up. How would I clean this up? Well, this is one term, this is one term. And you gotta talk to your professor about how much do you need to clean up each example. In this case, so we're gonna call it y prime, when we clean it up here. They both have a nice factor of 3x to the 4th plus x to the 9th. That is, if you understand factoring, I'd look up factoring, you can pull out from both of these a maximum of 3x to the 4th plus x to the 9th. You cannot factor this out because this does not have 10 power. It only has a 9 power. When we do that, let's see what's left over. Well, we're going to have a 2x still. We're going to have one of these left. You pulled out 9 of them. You factored out 9, so there's going to be 1 left. So I'm going to put a 1 there. Because when I distribute back in, I get that 10 back. And this, when I distribute back in, would be these pieces. I'm going to completely factor that out. So what am I left with? Well, I'm left with x squared plus 1 times a 10, don't forget your 10, x squared plus 1, and a 12x cubed plus 1. So now we're at this. Okay, we can continue on. We can distribute, we could FOIL, and then distribute it to 10, and collect like terms, and continue on our way of simplifying. Again, you got to talk to your professor about how much is simplified. Do you just need the derivative, or do you need the simplified derivative? You really got to read the instructions on your assignments. Now, what we're doing here, guys, is algebra. We're spending time on somewhere between 9th and 10th grade, or I shouldn't say just 9th to 10th, 9th through 12th grade algebra classes, you worked on this. That is, let me get a different color here. I'm going to distribute. All right, here we go. 2x times 3x to the 4th is 6x to the 5th. When you multiply like bases, you add the exponents. Got to know your exponent rules in calculus. 2x times x is 2x squared. All right, good. I'm going to forget about the 10 for now. I'm going to FOIL. Nice. I'm going to FOIL those two expressions together. What is FOILing? Let's remember. First terms get multiplied, so that would be 12x to the 5th. Outer terms get multiplied, that's x squared, because x squared times 1 is x squared. Inner terms, 1 times 12x cubed is 12x cubed. And last terms, 1 times 1 is 1. What's going to be really critical here is getting your parentheses right, because that 10 will get distributed to everything in the end. So you got to be careful. That's why I put that extra parentheses in there. All right, we're almost there. So my derivative, so I'm going to do a little arrow here. My derivative in, I guess what I would call simplified form, is 3x to the 4th plus x to the 9th. All right, let's kind of do it all at once now that we're at this point. So I see 120, because 10 times 12 is 120, x to the 5th. There's already 6x to the 5th. So 120 and 6 is 126 x to the 5th. Gotta be very careful what I say. So that's 120, and that's 6. All right, what's the next highest exponent? It'd be a cube. I see 1 cube, right? But it's 10 times 12, so it's 120 x cubed. Really, the struggles that students have with calculus is not the calculus. It's the algebra simplifying it. You just got to take your time and go through your algebraic operations. So we got the cube now. All right, so we have a squared term, and there's a squared term there. 10x squared, 2x squared is 12x squared. And last but not least, you have the constant, which is 10 times 1, which is 10. I'm going to write it here just to make sure it is on the board for you guys. And if I've done my algebra correctly, that is the simplified version of our derivative. Once again, you got to ask your professor which version they want. I just want to make sure I did it right. 120, 126, that looks good. You have 120x cubed, that looks good. You have 2 and 10 makes 12, and then you have a 10. Beautiful. And so there is my very first product rule. All right, so in my next two examples, I'm going to do them quicker and not so much worry about the simplifying, just because I want to make sure you have enough examples of the product rules to utilize. So now is that quiet space where you probably just want to fast forward in this video. I would. All right, so I need a new function. Got it. So we have our new function, x cubed, radical 3x to the 8th plus 10x, and just for kicks, minus 7 over x. All right, so I want to take the derivative of this. Well, there's actually a couple things going on here. First of all, the last operation would be the minus. That actually would be the last operation. So in fact, I really have two things going on. I want the derivative of this, and I want the derivative of this. So the derivative of this is a product rule. The derivative of this, good old power rule. So what I would do is I actually, whenever I see a plus or minus, I really slow it down. I really go, all right, what can I do here? What can I do here? And then together, I'll put a minus between them in the final answer. And so now, let me just look at this piece. I'll come back to that later. Looking at this piece, that is a product. Once again, because the last operation I would do when I evaluate would be the product when I look at this piece. Now, square roots. Look at a previous video. You'll know that as soon as I saw a square root, I'm going to do an algebra rewrite. Again, I can't tell you enough how to many students the hardest things about calculus is the algebra. So in this case, the square root actually has an equal partner as an exponent. You just got to recall the square root is a 1/2 exponent. Also, by the way, I can rewrite this. I can bring up any denominator by exponent rules by negating the exponent. Yes, that is a fraction. You could do the quotient rule. There's nothing wrong with that. I'm going to eliminate the quotient rule by bringing the power up. When you bring a power up, you negate it. All right, so how do I take the derivative of this? That's a product again. Why? Because it's the last operation. So I have my u, I have my v. And now really what you should do right now is pause the video, boop, and try to do this yourself and see if you come up with a similar answer. That's the great thing about these videos, right? Click, pause, see how you would do with the product rule. Of course, you can leave the product rule handy, like we had before. And so let's see how you did. Y prime. So the product rule is u prime v plus u v prime. And I'm going to leave a lot of space for v prime. So u prime v, u v prime. Beautiful. Of course, we have a minus. I do not want to forget this piece over here. All right, and in fact, I'm going to take the derivative of that right now just so I don't forget it. Because again, that is really the last operation, so that's really what I'm focusing on. Over here is a product, over here is this extra piece. And I want to go that extra mile to get full credit on my assignment. So how do I deal with this? It's power rule. You bring the power down. Well, this times this is actually I don't know how you want to write this, but a positive 7. That is negative times negative is positive 7. Please, the next thing you got to do is subtract 1 from the exponent. When you subtract 1 from the exponent, you get negative 2. And so there is my back end of the derivative using the power rule. Bring down the multiply. So when you multiply two negatives, you get a positive. Subtract 1 from that, you get a negative 2. Sweet. Over to here now. The product rule piece. The product rule piece, you have your u, please plug it in. You have your v, please plug it in. And I apologize for my handwriting. I'm trying to shove that in there. All it is this exact piece right in there. Really poor handwriting. This goes in there. Really, I just need these so I can look at them when I take the derivative. When you're writing up on a test or assignment, just take your time, write it up neatly, please. All right, the derivative of this, well, it's good old 3x squared. No issues there. The derivative of this, well, that again is a power rule, a chain rule. Please see my previous videos or future videos, depending on how you're watching this, on the chain rule, if you have a question about this. So you have parentheses power. How do I take the derivative of that? Well, I bring the power down. So the power down, boop, 1/2. Leave the inside alone. So we're leaving the inside alone. And we're subtracting 1 from the exponent. So that would be a minus 1/2. Again, power down, leave inside alone, subtract 1 from the exponent. This is the inside. And by the chain rule, you do have to take the derivative of that via the chain rule. That is, you bring the power down, leave the inside alone, and then you multiply, now I see I'm going to need more room now, you multiply by the derivative of the inside. So the derivative of the inside, slowly, is 24 x to the 7th plus 10. Now I got to make sure I got my brackets and everything correctly.